Okay guys, so in this video we are gonna go through the basics of interfaces, so let's get into it. So we're gonna cover what an interface is and why, well, like when they might be useful. So basically there is this idea, and that idea is an idea that we call loose coupling. So you may know that uh, when you're using inheritance, you will often find that you have a chain of inheritance, and very often you find that there is a fairly strong coupling between the entities that inherit from each other. As an example, you usually have some type of user, which then you might have a subclass of a user, which might be an admin user or a VIP user or something of this nature. There is always a very strong connection between the user and the subclass. And that is, it's a very good thing when the objects that you want to group together, or the functionality that you want to keep together, is very naturally coupled in one domain, if you will. So users, users and sub-users, that makes a lot of sense for them to be together, because the logic and the semantics around that class is very tightly coupled. However, there are situations where you may have a function, you want to express a piece of functionality, you want something to something that is common to happen, but you don't want to couple the actual implementation or the actual logic of how this happens together, because that's a very bad thing. An example, which is the example that we're going to go through here, is payment options and payment providers. If you have a system where you have a bunch of different payment providers who have their own payment flows and checkouts and stuff of this nature, it's what you want to express is that from your system is that you want to be able to just say, hey, this user is going to pay this amount, and they want to pay it through this provider. But you don't really want to create a coupling between the different payment providers, because the payment providers, like the actual concrete implementation of how they handle a payment, might be very, very different. It's not like a user and an admin, because they almost have the exact same logic and the same needs, but different payment providers, these are integrations to different systems, and sometimes very rarely is going to be the case that they have something to do with each other. So you want them to be completely separated, but you also want to be able to express that, hey, I need this payment provider, and I need some common interface for just handling that, for handling a payment, because that is the common denominator. And that is when an interface makes a lot of sense. So an interface is simply you stating that if you implement this interface, you need to implement a certain method, and that's about it. So let's walk through it. So if we go and have a look at our payment provider interface, so this is the way that we declare one. So basically we have this interface which we call a payment provider. And all a payment provider, in order for you to be qualified to be a payment provider within our system, all you need is to create a method that is going to handle a payment, and it's going to take a user and a cost. And it might also throw an IO exception, but that has more to do with the fact that, alright, we are going to make some type of network request. So this is just a formality. And then it's going to return a boolean, which basically expresses whether or not, hey, did the payment succeed or not. This is a very simple example, but this is the bare bone basic stuff, right? So if we look at our main function here, so what we're going to do is that when we start our system, our application here, you can see here I've already ran the code. We're going to create a user, and that user is going to have some type of cost or like a payment that is associated with it. We can actually, just for the sake of it, to go in and see here, this is a simple little user, and our cost is this little simple thing here. It's just going to be 1 Swedish crown. Amazing. And then we have this thing here, which we call a supported payment providers something. Let's go in and see here. So within our system we have 2 supported payment providers. We have Klarna and PayPal. Alright, and then we have something called payment handling service. Alright, so send payment, and then it goes and takes a user and a cost and then the provider. Okay, we can probably have a look at that. So let's go in here and see what's happening down here. All right, so when we have a user who wants to send us a payment or like pay for a product of some sort, we take in this enumeration and then we do something like this. Okay, so we have a payment provider factory, which is going to get a provider, and it takes our provider and then it returns a interface type, which is called payment provider. Okay, and this is the magic right here. So the thing is that we have a few payment providers. We have a few things, like if we have a look here, for example, we have a few payment providers. We have one that was named Klarna, right? So here is our Klarna payment provider. And this concrete class, this actual implementation of how to do an integration to this payment provider, it has all its own internal logic. As you can see here, it has its own instantiation. It has its own overall way of achieving this goal. The only thing it really has that is common between the only common thing between this Klarna implementation and the PayPal implementation, if you look here, now this is just basically copy pasted code, but you can use your imagination. It could have been a very different implementation. The only thing that is common is this one method here, handle payment, and that's the magic. As you can see here, we're implementing the payment provider interface, which forces us to have this method. And from our consumer perspective, that's actually all we want. All we want is to know that, all right, I need a payment provider, and I just need a method that will take the user and the cost that the person is going to pay, and some method that will deal with that for me. And then I need to know if that payment was sent, yes or no, so I can handle it accordingly. And what's happened here is that we have avoided because we don't really want to create a connection between Klarna and PayPal, because the implementations, and I mean, this is a very simple implementation. In the future, they might have their own subclasses or superclasses. It might get to a point where it's a very complicated implementation, and it's a very specific thing to one part of our system. But what we want, in order to avoid having too many specifics in our own code base, is to abstract away as much as possible of the actual concrete implementation and just have something that is fairly generic. And this is a very good use case for an interface, because now all we can say is that, hey, we don't really care like how we will look at the factor in just a moment, but we don't really care what else is on a payment provider. It can be one method, it can be 100 methods. We don't really care. All we really care about is this method here that will handle the payment, and that's it. And that's what an interface is meant to do. It allows us to say that, hey, I have some functionality that I need. I don't care who does it. I don't care about inheritance or stuff of this nature. I just need you to have this thing here and be able to do that in order for this logic to work. So if we look at our factory, which is a very common pattern in object-oriented programming, since instantiating or creating a PayPal or a Klarna class or like an instantiation which holds all of this information, it could be very different. In this case, it's a very simple implementation, but in theory, there could have been a bunch of stuff that needed to happen in order to actually set up this instantiated provider. But so having a wrapper around that, which is called usually a factory, it's called the factory pattern if you want to check that out. It's a very common practice where we can now simply state that, all right, we just, instead of having to handle all of this stuff up in our service that handles the actual payment, because that can get very messy, it's much nicer to, often it's very nice to have some type of factory where you just give it a label saying that, hey, I need a instantiated version of PayPal or Klarna or something like that. And what's returned to you is, as you can see here, the payment provider. I can break this by just saying, I can say Klarna and have that there instead, but as you can see now, the problem is then, all right, well, I can't return an instance of PayPal if I'm only going to return the Klarna provider. So by just having this payment provider interface on top, I can actually express that the object can be in any shape or the instantiation of this class can be in any shape it wants, as long as it has that magical method handle payment. That's all I care about. So having this way of working it's a very, like, having an interface or having the ability to use interfaces it's a very, very efficient method of keeping to create a common set of functionality between things that shouldn't be actually inheriting from each other, because sometimes you don't want the coupling between two classes to be that tight. And in this case, Klarna and PayPal, they don't really have anything to do with each other. They're completely separate things. It's just that they need to express that, all right, I need to handle a payment. So what I want you to take away from this is that the way to think about interfaces is to, when you want to avoid having an inheritance chain, you don't, because sometimes you want to make something inherit from something else, but sometimes you just want to express that, hey, I need this method or this functionality. And as long as you can deal with that, I don't really care about the rest. And this is a very strong use case for it, where you have a bunch of payment providers or something of this nature. They are going to do the same thing, but the way they do it is very, very different. And all you want to express is that, hey, as long as you can deal with this thing that I'm asking you to do, I don't really care how you do it, just do it for me. Hopefully this makes sense to you. Have a great day.